Welcome back. So, if you don't know me, my name's James. I'm a product designer, which I don't know, you can think of like an industrial designer or a mechanical engineer. And I am a hobbyist musician and a hobbyist YouTuber. And in this stream, I'll be working on a project that I've started with some friends called Live Drum Machine. Well, it's called that for now. LDM is the code word, and it's basically a drum machine hardware device, a digital hardware drum machine that you can play, and it should be playable in a very natural way, like you're playing an instrument or something, unlike a lot of other digital music production devices, which can look a little bit maybe boring to watch people, or it can look a little bit like you don't immediately understand what they're doing. So that's the goal of this project. And in these streams, I'm doing the mechanical design. So I'm doing CAD modeling in SolidWorks, which I have here. This is the second stream. I started the first one yesterday. And in yesterday's stream, I discovered a couple of problems. And since the stream ended, I've figured out the solutions for those problems. So I thought the first thing I would do is just give a bit of a wrap up on that. So if you're following along and you have the same problems, this is how you fix it. So the first thing is, for some reason, when I turn the edges off, I can see the color of the material here when it's on shaded mode. But if I choose shaded with edges, I don't see that bluish gray color anymore. And this should not look like that. That's a graphical bug. And I asked somebody in the forums how to solve that, and they very quickly gave me a solution. So thank you very much. And basically the way you fix it is by going to performance here in the settings and scrolling down to this one, enhance graphics performance requires SolidWorks restart. So this the fact that it's on is causing a problem because the most recent NVIDIA graphics card drivers are causing some problems. So turning that off solves it, but you also need to restart SolidWorks. So I'll close it, and then I have to launch it here from the 3D Experience platform, which will take a little bit of time. But yeah. Thankfully, somebody in the forums was able to respond to me pretty fast, within, say, 20 minutes or so. And I was able to get a solution for the problem. And I also asked some people on Reddit, and they also quickly helped me as well. So if you're, if you're not getting any help on the official SolidWorks forums, you can head over to Reddit/SolidWorks, and there's a lot of helpful people there as well. So if I open up that same part again, which is this one, now you can see when I turn on shaded with edges, everything's working properly. So I can see the color and I can see the black edges. So this is how it should look. And yeah, I'm just happy that it's back to how it should be. The second thing is I was having some issues with this part. You can hear the ding dong noise when I open it up. The infamous SolidWorks ding dong, which is a very frustrating noise because it means something's broken. And all it was that I just mental blanked, forgot how to do sheet metal stuff, because yeah, it's been a while since I've been using SolidWorks, but also like it's been longer since I've done a lot of sheet metal stuff. But I was trying to make these corners overlap using two edge flanges, and it just doesn't like that this edge flange is meeting flush with this one. But then I realized that there's actually features in SolidWorks already to create that overlap. So I can even just use one edge flange. I also don't need these circular cutouts that I put here before this. I can remove that. remove that sketch, and yeah, so in my edge flange feature, I'll just delete this as well. I'll start from scratch. So basically you want to put an edge flange. Well, not like that. What did I do? I clicked the wrong button, didn't I? Edge flange, not base flange. Sorry, delete that plane. So we click edge flange, then we choose, oops. What just happened? Oh, thanks for the follow. Sorry, I can't pronounce your name. Hey, thanks for joining the stream. Thanks for following. I've only just added the alerts there, so that's actually the first alert that I've had on stream. So I don't know. Take that as you will, whatever that means to you. You can feel special. Okay, so I added an edge flange on all 4 corners, and I need to make the edge flange taller. So I can edit the sketch and drag it up to this point of my skeleton model that I set up in yesterday's stream, and now all of the other sides are going to match. Just because I'm a little bit obsessive compulsive and I don't like seeing these little hyphens here, which means that the sketch is undefined, I'm going to define all of these sketches. You don't need to do this, but you know, I'm a weird guy, so that's what I'm going to do. Oops. Close that. And okay, so now they're all defined. Okay, so the point that I was at yesterday was that I made these flanges, but I wanted the corners to be overlapping. And I was trying to adjust the sketches in the edge flange to make them overlap, which doesn't really work. But there's actually already a feature here that I just forgot about called close corner. You just choose the face, and by default this is choosing an overlap, and it's going the right way that I want already. But I can switch it to the other way, or I can make a, what's it called, a butt join, but I want overlap, so that's good. And it might give me an error here, yeah, because I need to click open bend region. Not exactly sure what that error is, but clicking that solves it. Now, one thing I'll mention here is I did say yesterday that I want everything to be defined in my skeleton model, and there is something here which is not defined, and that is this distance. So this little gap in between these 2 parts, I'm not opposed to having a 0.1 millimeter gap there, but I would like to define that in my sketch so that my sketch will update all 4 of these corners. So what I'm going to do, save all. Gonna go to my enclosure top sketch. So this is the top view of the enclosure, and this is where the overlaps would be. And this part, there should be a gap here. So this is going to be okay to, this is on the midpoint. All right, I have to change a few things here. So I should be able to, no, I can't do that. All right. See, I need to make a few disconnections here. I need to disconnect these 2 lines from this line, and it's not going to let me do it because there's a lot of things constraining them. And especially when you have a line meeting, like a point of a line meeting another point of a line, there's no way to just disconnect them. So what I generally do is I need to remember what this is called. So I'm going to customize my toolbar here, and there's a tool, this one, detach segment on drag. So I'm going to add this to my sketch toolbar by just dragging it up here. And this tool, if I click it, it allows me to just grab a line and move it, and it'll disconnect anything that's stopping it from being disconnected. It's a very handy tool to have. And that one's still connected, so I can disconnect it. Okay. So now these lines, my scroll wheel. Now these lines are disconnected. I'm not going to join this to the midpoint. I'm just going to make it coincident. And then I'm going to cap this off at the end. Initially, I didn't cap off this section here because when it was joined to here, I didn't want to have a double line. Like I didn't want this line to be inside this line. But now that I've realized there should be a gap there, I'm going to have it capped off. And I'm going to put a little line in here to measure the gap. And I can make that 0.1. But just to demonstrate, I'm going to make it 0.15. Now you might be thinking like, why would I put this little line here? Well, let me show you. See, I could just add a dimension on this and say that that's 0.15. Okay. And then I can go down here but then I also want this gap to be 0.15. Then I have to put in another dimension or make this centered or something like that. But I find it easier to just put little lines in everywhere, like anywhere where I want one dimension to be carried over into multiple different areas. I'll just put a line there because then I can just make the lines all equal to each other. So I'll put this little line in there. And I put a little line in here. And grab that one. And this one. And make them equal. And now I don't need to dimension this. Because I've dimensioned the top one. It's going to tell me that it's overdefined now. So I don't need that dimension because this is copying the same dimension from up here. You have to excuse me when I have to zoom in and out a lot like this. It's it's the encoder on this scroll wheel on this mouse. As you can probably tell, I've made a lot of changes to this mouse. Some of them are quite ugly, but one thing that I haven't done is replace the encoder for I've replaced these switches, but I haven't replaced the encoder. I've also replaced the scroll wheel, but I have some encoders here from Kale, and I've been meaning to swap them, but I just don't have access to a soldering iron at the moment. So at some point I'll probably take them into work and ask one of the nice guys in the electronics lab to do a nice solder join for me. But yeah, so when I'm scrolling in and out really quickly, sometimes it doesn't do what I want it to do. So I'm gonna detach these lines as well. And then I can turn off this detach segment on drag. Cap this off. Oops. And And what's happening down here? Then I'll make that, oops, make that equal to that. And that one equal to this one. And these I'll just make collinear. So collinear just means they're along the same line. So now that's all defined, and those gaps have a 0.15 millimeter gap. Technically, like, I don't really need this here. Like, this doesn't really need to be reflected in the sketch, because I'm going to link that gap value to this dimension in the actual feature of the closed corner. But I like to make my sketches look accurate in case I want to link something else to these points. Okay, I'm going to save and go back to this part. Nope. What happened? Did I close it? Okay, so so remember here I have a gap of 0.1 millimeters, and I'm going to go to my equations, and if I look here I can find that my sketch, my LDM SK, which is my skeleton model, I have that 0.15 millimeter here, and I want to take where is it? Maybe I can't reference that one. Okay. Can I put an equation in here? Is this if I can just put a... maybe this can't accept an equation. Okay, that's a little bit annoying. Let me try something. Nope. Okay. Turns out I can't put an equation in there, but at least if I put a 0.1 millimeter gap there in my sketch, sorry. Come on, there is no equation there. So at least I can have this in my sketch that I'll just have a 0.1 millimeter gap. I'm gonna have to just match that until SolidWorks changes something. Still don't really understand what this lock thing means because I'm not used to the SolidWorks PDM server or the cloud stuff, but I will lock it. Okay, so I need to do the rest of my closed corners because unfortunately this feature only works on one corner. So do another one there. Another one there. And another one there. Okay, now the next thing is these corners look a little bit weird, as in this 3 vertex corner, this 3, I don't know what you call it, a 3 line corner. So I want to change this. Which corner am I looking at? Yeah, I'll start at this one. So there's also another SolidWorks feature for this called corner relief. And I can collect all of the corners. And I can try some different corner styles here. This is a 2-bend corner, I think. Yeah. So then I can center the corner on the bend line, and the rectangular corner is essentially what I already have, so I can just make it bigger. I can make a circular corner, which looks a bit weird like that, but if I go 2.5 or so, it'll make a sort of circular cutout in the corner, which actually I think is probably preferred, but I'll show you what else there is. You can do a tear, which is really like a lot of overlap. And I mean, this closes the gap the most, but it means you have, like when you do the flat pattern, so if I unfold this, oops, not unfold, flatten, you have a sharp corner there, which it's fine, but it's not ideal. A curved corner is much nicer, especially for laser cutting and stuff. So, I'll show you what other ones we have. Obround, I'm not sure how you should pronounce it. But also I don't know if this will work on this corner. No, maybe not. Constant width, it's similar to tear. But at least with constant width, this corner here is radiused. But we still have a sharp-ish corner. They've slightly rounded it. But still not ideal. So I'm going to go for a circular corner. Circular on all of them. And I'm going to make it as small as possible. I think 2 is too small, so we'll go. Is that going to work? Yeah, 2.1. So that gives me a little bit of a weird looking corner, but once I flatten it, you can see this is something that's much easier to laser cut. And what I'll also do is add fillets. Oops. So I can add a 1 millimeter fillet there and there, there and there. There and there. Okay, so now I have all curved or filleted edges, which is much nicer for laser cutting, because it means that the laser cutter never has to have like a sharp point where it stops and then goes in a different direction. It'll smoothly transition to the different direction, which means you get less sort of vibration and weird stuff happening on the cuts. I can flatten this. This is my flat pattern, and yeah, you can see that a laser cutter will have a much nicer time traveling around this smooth curve. So that's pretty cool. One more thing is that in my enclosure top sketch, I added these filleted corners, and the reason why is what I would like to do is round off these corners. Some manufacturers don't like doing that, and some of them are okay with it, but you can actually ask them to round off an edge, which will just look a lot nicer on this device. So I'll get the top plane, and I actually have this top plate sketch which I use to define the top plate, the shape of the top plate, so I can use that exact same sketch and convert it, and then I'll just cut through through all, reverse, and that's going to cut out everything in the inside and leave this part, so I want to flip the side to cut, so it cuts the outside. There we go. So now I have all the corners rounded like this. I didn't do it with a fillet. The reason why I didn't do a fillet is because I added a fillet here. If I add a fillet to this line, it's not going to know what to do at the bottom here. So I could also put it before this fillet, but then so it should be 2 millimeter radius, but then I can't fillet this edge because this is also this edge, so then this one's not going to know what to do, and you can see that it's erroring out there, so it's better to just do a cut. Okay, so that's the bottom of the enclosure. Then I can open up the complete assembly. Yes. Rebuild, and I can turn on shaded with lines. And there we go. We have the top and the bottom attached to each other. So this is a very basic sheet metal enclosure. A flat sheet top and a folded sheet bottom. So if I can just bring up my where are they? I want to bring up my inspiration images. Okay. So we have some devices here for inspiration. So yeah, like I said in the stream yesterday, we don't know exactly how this device is going to look yet. We don't know if it's going to have pads or if it's going to have just buttons and knobs and things, and so it's probably going to have a mix of a lot of these different things. So I'm just going to add things to the model so that we have everything there and we can choose how many buttons we want, and we can rearrange things and basically just set it all up so that we can start being flexible with arranging it. So I'm going to try putting in some things like a PCB for like a main PCB for everything to connect to. I can put in some jacks, maybe also a sub PCB for the MIDI jacks, and yeah, some knobs, sliders, those sorts of things. So I'm going to yeah, I think I'll start doing some enclosure sketches now. How am I going to do this? Should I do the top plane first or the side? I think I'll do the top first. So I'm gonna make one giant PCB that covers the whole thing, because there will be stuff everywhere. There's gonna be buttons, knobs, screens. There should be no reason that I can see to have an area of the enclosure that doesn't need a PCB underneath it. Oops. Actually, that was a bad idea. So I'm just making a big rectangle with curved corners. And I don't use fillets because fillets sometimes break. And it's easier to add relations to curves like this. Gonna make all these the same size. And they'll probably be like 2mm radius. Oops. The whole thing got smaller. Gonna put these lines in here, which are just gonna dictate the distance to the edge, because there's really no point in deciding the size of the PCB and just letting that dictate how close it comes to the edge. I think it always makes more sense to keep the distance to the edge consistent, and that dictates the total size of the PCB. But sometimes you want the distance at the back to be different, so I'm actually gonna make this one independent. The reason why is that the jacks might need to be a bit closer to the edge of the enclosure. So and you might, when you insert the PCB, you're gonna like put it into the enclosure and then move the jacks through the holes in the enclosure. So you might want it to come down like this and then have a little bit of space to go like this. Yeah, so to that distance I'll keep it independent. Oops. So the other distance, I make this 1 millimeter. Okay, and this should be 2 millimeters. The big ass PCB. Can I rename this or what? Okay. Then I'm gonna use the right plane and look at the enclosure, and then I'm gonna decide how high from the top surface the PCB should be. So I can make a rectangle like this with the PCB thickness, which usually tends to be 1.6 millimeters, but we can always change that later. And I'm going to hide this for now. And I'm going to align this edge with the top view so that the width is correct. And then usually the height of the PCB is going to be determined by the tallest component that needs to go on there. So that's probably going to be dictated by whatever components we put on there, like mechanical switches and stuff. And I'm not exactly sure how tall the mechanical switches are going to be yet, so I'm just going to put in a random value. So we'll say, yeah, the PCB is 10 millimeters from the top, and yeah, that should be fine. Why is this not? Okay, I have to right click it. PCB right. So now I'm going to make a new part, which is going to be the PCB. So I'm going to make a copy of this part, save as new, save to this PC, save as a copy and open, and I'm going to call it PCB 1. Okay, now I can delete everything except for the inserted sketch. It's gonna do this to me again. Yeah, there's no equation there. That's where it is. Okay. So because those last two sketches were just added and everything else was hidden, they've been brought into here and they're shown. So I can convert this entity and I'm going to extrude from that vertex up to this vertex. Yeah, this is the thing that I love about SolidWorks, is extruding from vertexes and up to a vertex. Okay, so I have my PCB now, and the material is set to aluminium alloy. So I'll change that to something more appropriate, like fiberglass or something. Generic glass fibers, I don't know. E-glass fiber, I don't know what that means. Electrical? Close enough. And just so that I recognize that it's the PCB, I like to just give it a green color. So I just clicked on appearances and just a basic appearance and just made it green. I'm not doing any rendering or anything, it's just for my recognition. And I'm going to save it. Come on. Phew, that's a long one. See, there's a couple of people joined in on YouTube. Let me know if I'm just being super boring or if I'm just like spewing too much information. Also, if you have something to talk about, just write a message, you know, you're not interrupting me. We can also talk about something else other than CAD. If you're a designer, then let me know. Or if you're interested in drum machines, or yeah, tell me what's happening. Okay, so I'm gonna hide all these sketches. I'm gonna hide this, and then I'm gonna insert the PCB. Boom. Now, because everything is linked to my skeleton model, my skeleton sketches, when I drag this in, I don't need to do any mates. It's just exactly where it needs to be, because all my parts are built around the same skeleton model. So they're built around the same location, the same positions and widths and everything. So I drag them in on the origin and they're exactly where they need to be. I can put the top back on. Yeah. So this is what we got so far. A box with a PCB in it. Now what next? Okay. I'm gonna give some options for what I can do next. And if anybody gives a shit, you can vote in the chat. Otherwise, I'll just decide. So I can either start adding in knobs. I can start adding in a display, like an LCD. I can add in a keyboard switch, like a mechanical switch, or I can put in some jacks, like ports on the back. So I'm gonna give you 10 seconds to think about it, and if no one says anything, I'm gonna choose. All right, I'm gonna choose. I think. What should I do? I think I'll do some kind of basic mock-up of the display. Even though we don't know what display model we're gonna use yet, I'm gonna put in something to resemble a display. Yeah, I'll do that. So what I usually do when I want to put in components from somewhere else is I roll back to the very beginning of the feature tree and I put in sketches. This is in my skeleton model, by the way. I put in sketches from components. Ideally what I'll do is like I'll have a component made somewhere else in another folder that also has a skeleton model. And if I'm going to use that component in this device, then I'll import that skeleton model in here and I'll reference that. So if I have a display and I bring in the sketch in here, then all of my cutouts for the display and everything will be based off the skeleton from that display. And then if I realize later, like, oh, I actually messed up the dimensions of that display when I 3D modeled it, I can go into that 3D model, fix it, and then it should update everything here. So because I haven't chose that display yet, I'm just going to make up some reference sketches for it. And I always put them at the beginning before my actual sketches here, so that everything in my skeleton model can reference those other components. So I'm gonna make up a display which is essentially a 16 by 9 rectangle. How can I represent that in an equation? So let's say it's going to be a 7-inch display. That means this line is 7 inches. If I enter 7 inches, it will give me the millimeter value. Then this needs to be a ratio of 16 by 9. So how can I do that? I actually need to make it a ratio of this. I need to do some trigonometry. It's been a while. Oh, wow. My brain. I'm tempted to just break this segment into 9 pieces and break this one into 16 pieces and then make them equal to each other. God, why can't I think of how to do it? Whatever. I can't. But this is maybe a good trick just to show you that you can define things purely with geometry rather than with equations, which in some cases is useful. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and make them all equal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And then I'll go 1, 2, 3, 4, 5, 6, 7, oops, 8, 9. I kind of messed that up a bit, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then I can just make these two equal to each other. Boom. 16 by 9 ratio. So that's the display area. But generally a display is larger than the actual display area. So, oops. My bad, I pressed the wrong button. This might actually be over-defined. Nope, it's fine. Let's say that's like, I don't know, 10 millimeters larger. Might be less. And I'll put in some lines here. You'll see why in a second. Okay, I think that's fine. Display top. Oh, because this is a component, I usually put a little underscore before it just to indicate to myself that it's a component, and then all the real sketches start after that. So now I imagine it would have some glass on the top and then and a body underneath. This is very basic. I'm sure the real display will be more complicated than this. Okay. Glass would be probably, I don't know, maybe 1 millimeter thick. And the body, I don't know, 5. Six millimeters thick total. What would that look like? Why is this always here? Ooh. What the hell happened to this? Anybody seen that before? That's not good. I think the battery was squished down on top of it in its case. That's really not good. Well, I have to try and fix that. 6 millimeters is, yeah, that's pretty thin. Seems about right though. Display right. Okay. So now, now I'm just thinking, do I want the layout to determine the PCB size? Or do I want the PCB to determine the layout? I think I'm going to add parts to this PCB top. Yeah, I think that's what I'm going to do. Okay, so I've got my reference sketches here. And I'm going to make a movable version of this. So I'm going to have my I'll just draw it over here. And you'll see why in a second. Just gonna make a little X. Now all I have to do is make this equal to this. this equal to this. This equal to this. That equal to that. That equal to that. And that equal to that. And if I lock that under something, everything's defined. So that means I have a movable copy of my display with no dimensions on it. And the nice thing about that is that I'm not going to make this sketch crazy full of dimensions. I can just use dimensions in this sketch for locating things. So let's say we want to display in the middle somewhere. And I show the top, the enclosure top. I can make it a certain distance from the top plate, the edge of the top plate. I don't know, I'll make it like 40 millimeters. We might put buttons or something along here, so it might need more space or less space, I'm not sure yet. Let's make it 50 for now. What else? Oh. I might add corner radiuses onto here. Do I want corner radiuses? I'm just going to do one. Because the hole in the top of the device should have radiuses in the corners. As in the hole in the metal that looks through into the display should have radiused corners. I think I'm going to make I'm going to take that out of here because that's not relevant to the display itself. And I'm going to make another sketch, which is like the enclosure top holes. So it's just going to have the holes that get cut out of the top, and they're going to be informed by all of the stuff that's on the PCB. So okay. Actually, I can just trim these and then I can just link these to the sketch underneath. Make all these corners equal, and I'll give them 2 mil radius. Gonna call this sketch. Come on. Top holes. Okay. Gonna my enclosure top plate. Already got a top hole sketch there, and I'm gonna convert it. Extruded cut through all. Oops. There we go. Got a display hole. Nice. We've got a box with a PCB and a display hole. Now I should make a little mock display to put in there. So, yeah, actually, that's where I should have put the sketch. All right, let me give you some behind the scenes. So what I'm gonna do is, this is my project folder for this project. I've got a research folder with my inspiration picture on it, and I've got my CAD folder here, which is 0.1 LDM. And when I decide to make a new version of this, I mean, this is how I would do things before using PDM. Now I'm using PDM server, so maybe I'll just do the versioning there. But this is how I do like hardware hard copy versioning. So in this folder has all of my parts. So the skeleton model, all of the components, and the assembly. Then I want to have a components folder where I'm going to put in electrical components and things, which is separate to this. You can think of it like a library. And normally I would just have like a global library, but I do have a global library full of lots of stuff that I've made over the years, but that's all from uni and old jobs and stuff where I was using SolidWorks Premium or SolidWorks Professional, and I don't want to have to like save them now in SolidWorks Connected and make them all SolidWorks for Makers. So I'm going to treat this separately. I'm going to put my own components library in here. So I'm going to call it components. And I'm going to put a folder here called example display 7-inch. Okay, so I'm going to start with a skeleton model in there. So I'm going to copy this make a new part. Change the background to white. Paste and attach it to the origin. Okay. Come on, why is it? Here we go. Top reference. I'm gonna save this and call it example display, like this, SK. Need to bring in the right sketch as well. Okay, so I've essentially just made the same thing that I made before in the... Oh my god, why is this so hard to rename these? Rename. You should just be able to click on it twice. Right, reference. Yeah, I've done the same thing that I did in the actual skeleton model before, but I want to replace that with this. So I'm going to go back to that skeleton model, and here I'm going to insert part, example display, and just sketches, and then PCB top. I need to remove my external references. That one. I think I can just remove all of these. What's this? That's fine. Okay. Okay, so now I've removed all those references. I no longer have any parent relation to this sketch or this sketch, so I'm going to just remove them. Is that okay? Yeah, that's parent to that, and that doesn't have any children. Okay. So I'm going to do those same links, but to these sketches. So this is equal to this. This is equal to that. It's a little bit hard to see what's going on here, but I'm essentially doing the same thing that I did before. Okay, so now my display, my movable display element on the PCB layout is referencing the sketches that I brought in from this other skeleton model. Okay, so if I go back and change that skeleton model for that particular part, it'll get updated here. And this means that I can use this skeleton model in other projects as well. So it's part of my component library now. And then I'm going to make an actual model of this display using its own skeleton. What am I doing? So I'm going to insert its own skeleton. And then I'm going to do a piece of glass. Extrude it from the vertex up to this vertex. Okay. And gonna set the material to glass. Where would that be? Yeah. Okay. And actually maybe I don't want to do that yet. Just because it's going to be hard to see what's going on. Then I have the display body, which will extrude from here to here. Oops. And I'm not going to merge these bodies. I'm going to keep them as two separate bodies. That way I can give them different appearances. Okay. That's my display. I'm going to call it example display 1. Call it 0, 1. Gonna give it the glass material. Now the reason why I set materials for everything as I'm going is then if I go later to calculate how heavy the device is going to be, I don't have to do all this work again. So once you set the materials for everything, it applies that density of that material, which means that it'll roughly know how heavy something of this size made of glass would be. The whole thing's not going to be made of glass, obviously, like the body might have some other materials in it, but it'll be close. And I'm just going to put a normal appearance on this body. Or maybe I'll change the color. Just make it like gray or something. Okay. That's our display. For now, a very basic display. Now this is where having a skeleton model is useful for aligning things. Because my example display is a component in its own library. It's in its component library. It's in a different folder, and it has no idea where it's located in this device. So if I just bring it in, oops, not that one, this one. It's down here because yeah, it doesn't know that it's supposed to be up here. And what a lot of people would do is set this to float so I can move it. Oops. Yeah, that's going to be annoying actually. Because it's glass, it thinks it's transparent and it allows you to click through it, which is a bit annoying. So I think I'm actually going to make the material something else. It's ABS plastic or something. Yeah, that'll be fine. No, that's ABS polycarbonate, which is also has the same problem. Because it's transparent, you can click through it. ABS. And then I'll give the top an appearance of glass. Wait. Just this body. What the hell just happened? Okay, good. So I can move this around, and what a lot of people do is they take their mate and they choose the top surface and they go, that should be the same level as this surface, and then they'll drag it where they want it to be and make some more mates. But the problem is, if I made it to this top surface, like to this part, it might be that I delete this part, or that I get rid of this part and replace it for something else, or I make a new part, or I make a different version of this part and I want to swap them out or something. And as soon as this part's gone, then that mate is gone, or that mate will fail. So I never mate parts to other parts, because then you're assuming that that part is always going to be there, and it might not be. But the thing that will always be there is the skeleton. So I only ever mate things to the skeleton. So I'm going to find my PCB top, show it, and I know that the right plane and front plane should be around this point, so I can take my front plane and mate it to that point. Take my right plane, mate it to this point as well, and then the top plane, top plane's going to be below the surface, and I haven't dictated where that will be yet, so let's do that. I'm going to put that in my skeleton. So I've got my PCB top, PCB right, and I need to make a movable version of this display for my PCB right. So I'm going to show this. Actually, I'm just going to copy that. Oh, I can't. No, so I'm going to go. It's just two rectangles anyway. And they're center aligned. make them equal. Now that should be fully constrained. Yeah, so now I have a movable side view of the display. And I'm going to link that to its position on the top view. And now I can decide how far up it's going to be. At some point I'm going to have to put in some kind of display protector, and that will determine how far down this should be. For now I'm just going to make it like maybe 1 millimeter below the surface of the enclosure. Okay. Oh, why did I do that? I did it on a new sketch. When it should be on the PCB right sketch. I have to do it again. Let me just check that's defined. Yep. Okay. Line it up with the top view. And bring it up here. One millimeter below the top surface. That should do. So go back to my assembly. And everything is defined on this. Oh. Right, I need to stop it from rotating. So add a plane, top plane to top plane mate and make it parallel, just so that it doesn't rotate. And I'll do the same thing with the front plane and front plane. So now it should only be able to move up and down. So I just need to show my PCB right, and I can mate this to the top in the sketch. There we go. A fully defined mated display, and it's only mated in to the skeleton model. It's not mated to any other parts. So if I was to delete this part, that's still there and it's still fully defined, fully mated. And if I move the position by doing this, actually let me just bring back the top plate. I'll make it transparent. You can see if I edit the skeleton and move the position of the display, everything's going to update. The hole updated, the position of the display updated. Mwah. Chef's kiss. Gonna move that back 50. Okay. Now I need to put a display protector And this is going to be an issue. Oh my god, what is going on here? I really need to find out what this lock thing means. Alright, so paint. So, normally, like, say I have the enclosure top like this. Right, this is a bad drawing. What a lot of people do is they make, so they have a display here. This is looking from the right, by the way, right view. I think I need to get a pen and paper so that I can just draw things here. Oh my god, why is this stopwatch always here? Yeah, so what a lot of people do, and what I've done before, is you make a display protector. And display protector is essentially a piece of plastic that goes above the display to stop you from actually damaging the LCD. So what you would do is have something that's shaped like this. And then that slots in from the inside, and you can stick it on with glue or whatever, or the display itself can hold it in. But it has two problems. One of them is that because it's attached in this direction, if you were to push it in this direction, it's possible to dislodge it. So if it's glue here that's holding it in, you could break that glue connection. And if it's the display itself that's holding it on, then pushing down on it is actually directly pushing on the display, which is also not great. Most of the time it's probably fine, but it could be possible to damage the display. So the alternative is you attach the display protector from the top. And a nice way you can do that is by, how do I make this brush bigger? I don't know how to use paint. A nice way you can do that is by, whoa. What brush was I using before? This? Yes. You can have a recess in the top of the enclosure, and then you just have a flat display protector that goes in like this. And that just reminds me, I forgot to mention the second problem with the last design was that because it was shaped like this, it has to have this part cut out of the plastic. So you need to do that with like a CNC mill or something, which, that's totally fine, but it's an extra process that you have to do. And it's also something that has the potential to fail. They might not cut it down to the right height, or there might be some variance or whatever. It can be very annoying. But making a flat sheet like this is much easier because you just have to make sure that the thickness of the material is right, and then you just stick it down, and that's all you need to worry about. And it's very easy to cut out a flat piece of glass or acrylic or whatever you want to use. Now the problem here is that this requires that the enclosure is machined, which is another step, like I said just before. So yeah, that makes it a bit tricky. There's ways around it. I'm just not sure what the best way is right now. But what I'm thinking is, what am I thinking? I'm thinking that we could, well, if you have a flat piece of metal like this, I mean, you could just stick the plastic on the top. It's probably the least good looking option, even if you have some frame around it, which, I don't know, could go down on an angle like that or something. It doesn't look great. But what I'm thinking we could do is attach another piece of sheet metal, and they could do this in the sheet metal factory just by welding it on, basically, like this. This would be a full ring that goes around, and then you just put your flat acrylic sheet in like that. Yeah, that could be an option. Have to think about it. Yeah. Don't know, I need to think about that, I think. Anyway, so I might leave the display protector for now. So I've just got the display there and a hole in the enclosure. Yeah, maybe I'll try another part. Or maybe I'll put in the display protector, but I'll just make it not make any sense for now. I'll just put a plastic piece that fits in this hole. And by the way, if you're looking at this and thinking, this looks really weird, like, why does the perspective seem weird? It's because I don't have perspective turned on. That's what perspective looks like with it on. The reason why I don't have it on is because when you look at a front view or something like this, you don't see the device always front on if you are moving around. But if you have it perspective off, it's always a front view. It's just more, I don't know, it's more accurate. But this is more like how we would see it with our eyeballs. Okay, I'm gonna make a display protector. And close this and this. make a copy of this. Oops. And it's part of the enclosure, so I'm going to call it ENC for enclosure 003, save as a copy and open. I can delete all of this. Delete the equations. Yeah, for now I'm just going to do a really basic display protector. And I'm going to make the material ABS polycarbonate. Okay. Now I have a display protector in there. You can barely see it, but it is there. There it is. Alright, what next? Knobs, buttons, jacks. I need to find out if I can get a CAD model of like a mechanical keyboard switch. Which I'm not sure of right now. Let me have a look. Actually, maybe I'll look for those later. Right now I'll do jacks. Just trying to find the right website. No, there's so many different Amphenol websites. Okay, this is the one. Let me show you. So, Amphenol Audio, Amphenol Australia, represent. We're gonna put, I don't know if they have MIDI jacks. I can't remember. Maybe not. Anyway, I'm gonna get, what am I gonna get? 1/4 inch, aka 6.35 millimeter. And we want M series single. 1/4 inch horizontal PCB or vertical PCB could be interesting. I'll get both. Without thread? No, there is none. I'm gonna do the horizontal PCB one. And probably without nut, plastic thread. What's the difference between these? I can't see any difference. This one has a 3D model though. Now, some people say like you should have a metal jack with a nut on it. And while I agree that that is nice, I mean, it looks stronger, I guess. I don't feel that it's necessary. And it creates more steps in assembly. And I mean, a jack like this with 6 pins soldered into a PCB that's screwed into the enclosure is not going to break. I mean, there's a chance if you tilt it, maybe it could pop through or something, but very unlikely. Danielle, Nicole, what's going on? How's the weather in Berlin? Actually, it's terrible today. It's like rainy and just bad. Good day for streaming. How about Melbourne? It's 14 degrees. It's not that bad. It's just wet. Let me just see where I put this file. Feel that, dog. It's rainy here too. Rough. At least we have mushy season. Nice. Yeah, that definitely helps. Of course, we're just talking about cooking mushrooms, I'm assuming. Let me show my screen again. Okay, so I downloaded this model. Where is it? Here? Totes. Good, very good, very good. Okay, so here's my jack. Let me put it in a folder. Phenol. And I'm gonna put that name. What's been happening, Daniel? You're making music and stuff? I'm also gonna separate these components by type. I'm gonna put a folder for jacks because there's gonna be a lot of jacks. Well, a few jacks. Hell yes. What kind of music are you doing? Just had band prac today. Nice. Hey, I don't know, you would appreciate this. I saw that that Steve Judd and fuck, what's his name? The bass player from Carnival. I forget his name. I mean, I know it. It's just not coming to me right now. But they made a new band called I can't remember anything. They made a new band. Let's put it that way. And it's like a prog rock band with some other people. Lunacy, I think it's called, but spelled John Stockman. That's it. Yeah, yeah. The band is called Lunacy, like spelled weird. I think it's something like this, like something like that. And I assume it's pronounced lunacy. Hmm. Yeah. Just thought I'd let you know because I think they put out their first single just like a few weeks ago. Okay. I don't know how much of this you've seen, Danielle, but I'm working on a drum machine design. Sounds like Tesseract. Cool, cool. Oh, I forgot to respond before. You said synthwave slash dark electronic. Nice. How many people are in the band? What kind of and what are you singing or? Okay, so here's my jack model that I downloaded from Amphenol's website, and I'm gonna save a I'm gonna save it as a SolidWorks part, and I want to break links to the step file. Now I have all the individual bodies, and kudos to Amphenol Australia for actually making decent CAD models with separate bodies. And I was going to say aligning them well to the origins, but okay, the middle plane's good. But I think I want the front plane at this surface. Best of luck with the project. I'm a good plan. A high school reunion. Shit. Wasn't that meant to be like 3 years ago? 3 and 4th member who jumps on for gigs. Yep, singing, tinkering with synths. Nice. That sounds awesome. I'll check it out. Have you got some recordings or something? That's okay if you're gone too, don't worry. Although I think I can see you're still there. I don't know. Yeah, I remember we were supposed to have a high school reunion like 3 years ago, and it just kept getting postponed because of COVID. But I'm also on the other side of the world, so it was a bit hard. What do I want to do? Okay, this is going to seem a little bit backwards, but I'm going to move this part. What am I doing? I don't need that. I don't need that. I don't need that. Don't need that. Oops. Uh-oh. Can I not move? Alright, whatever. Move / copy bodies. Move. I'm gonna add a mate. Oh. This face I want to be on the front plane, and then I want the top plane to be the point where it touches the PCB. Okay, and then the right plane I think is already in the place that I want, which is right down the middle of the jack. Now this is a very OCD thing, but I don't want this move copy feature here. I just want it positioned like this from the beginning. So I'm gonna save new, and I'm gonna call this like temp. Save as, and I'm gonna save it as a step file. Okay. Then I'm gonna delete this SolidWorks model and I'm gonna open this in SolidWorks. Okay, so now it's like I don't want that. God damn it. Can I undo this delete? Yes. Save as new step, and there's an option to make it so it doesn't put split periodic faces. I do not want. Okay. So now I'm gonna delete that. Then I'm gonna open this one. Okay. Change it to plain white. Disconnect. Break the link. Yes. And now I can save this with the original name and with the good alignment. Very OCD thing to do, but that's me. That's me. And I can delete this. Cool. Then I will set a material to some kind of plastic. ABS will be fine. Like that. And I can set a material for, wait. Aluminium. just make it matte aluminium. Oops. Aluminium, matte aluminium, and put it on these bodies. Very cool. Okay, there we go. That looks like a pretty good jack. What do you reckon? And then I want a little skeleton model that I can insert into my parts. Which I think I'm just gonna not have it as like a separate skeleton model, but rather just part of this. I can hide the bodies. You can see my sketch. I'm gonna link that to there, and that to there, and that to there. Come on. There we go. I'm just gonna check that none of these dimensions are weird. 21.4. 11, 9, 3.5, 5.5. That's a bit of a weird one. 6.43. Interesting. Just putting these here as labels, because I'm going to go on Amphenol's website and I'm going to check that these dimensions are accurate for like the data sheet. Okay. So let me just check. It was this one, I think. Yeah. $21.36, 24.3. Well, that's not right, is it? That's right. Is there anything critical that's off? 6.43, that one is right. 15.75. Oh yeah, that's right. And 6.43 is right. Need to add in the height afterwards. So I think that's good. I think I'll also put in the pin locations. What should I do? Hang on. Should I put the pins in? Yeah. Yeah, why not? Alright. Just gonna do it like this. 1, 2, 3. 1, 2, 3. Just checking the time. Okay, 4.25, 10.6, 16.95. Okay, 4.25 from here. Was it 10.6? Hmm, 10.6 and 16.95. And then how far are they from the center line? So they're 11.43 apart. And 4.2 from the center line. And there's also a locating pin, which is 3.8, 5.1, I say 3.8? That doesn't seem right. 13.8, 5.1 from the middle. Okay. And the diameter is location pinhole is 2mm, screw hole optional. What? Because it's got a screw hole there. Whatever. I'm gonna do a 2mm. One thing that I'll do on this, just so that I can make like a movable model, is I'll just put a line here to measure the offset from the edge. Oh, okay. There's a lot more to do, but I'm just thinking I have some other stuff to do. I need to go to a shop before 6 o'clock, and it's 4:45 now, so I might leave. So next step would be to create another sketch like this on the top plane. Then I can insert this part into my skeleton just as sketches, which will be like this part that I inserted here, which for some reason has a question mark on it. So I'll insert it as a component here that I can reference. Then I can place the jack on the PCB layout and then get the position where I want it to be. Then I can go back to my assembly and I will add the actual jacks into the assembly, and I can add holes in the back for the jacks. So that's what I'm going to do when I come back, or next time I stream. Until then, thanks for watching. Hope you learned something. Hope you got something out of it. If not, that's fine. But if you do like it, would very much appreciate wherever you're watching to give a like or a subscribe or a follow if you're on Twitch. And the mages sorry, I can't pronounce your name properly. Thanks for watching. Thank you. And you also have a good I'm just teasing. Yeah, thanks heaps for watching. If you're into this kind of stuff, follow along. This project is only going to get more and more exciting the more parts get added. Right now it's, it's a box with a hole in it. But you got to start somewhere. And yeah, it's going to get cooler and cooler the more stuff we add. So yeah, if you're into design, if you're into music making, if you're into making instruments, those kinds of things, or if you know somebody who's interested, let them know. And yeah, very much appreciate you watching, and have a great day. See you later.